Section 10.3, Angles and Triangles. Our goal today is to classify triangles by angles and sides. Remember to completely fill out your note sheet based off this video. We'll start by classifying triangles by angles. We have an acute triangle. This is a triangle that has three acute angles. This should hopefully be very clear to you when you see the given triangle. We have a right triangle, a triangle that has one right angle. Look for that little symbol in the corner to know it's a right angle and thus a right triangle. And in a right triangle, if one angle is 90 degrees, the other two angles must be acute. Finally, we have an obtuse triangle. This is a triangle that has one obtuse angle. And again, like the acutes, it should be easy to see by the triangle drawing. So we should be able to identify the type of triangle we have given angle measures. Let's get rid of that. So a triangle with three angles, 40 degrees, 60 degrees, 80 degrees. Those are all acute angles. Therefore, we have an acute triangle. Next, we look at a triangle with measures of 45 degrees, 35 degrees, and 100 degrees. Well, one of our angles is obtuse. Therefore, we have an obtuse triangle. And finally, I'm sure you can guess what this one's going to be. Angle measures 90, 76, 14. We don't care about the other two. We see a 90-degree angle. We know that we have a right triangle. So classifying triangles by angles. We can also classify triangles by their sides. An equilateral triangle is a triangle with three equal sides in length. In length, we look for those little tick marks. This tells us these three sides are the same because there's one tick mark per side. We have an isosceles triangle. This is a triangle that has at least two sides of equal length. Let me underline that, at least. And finally, we have a scalene triangle. This is a triangle with no sides of equal length. You notice there are no tick marks on that triangle. Therefore, no sides are equal. Let's use that knowledge to classify triangles by their side lengths. We have a triangle whose side lengths are 3 feet, 2 feet, and 2 feet. Since we have two sides of equal length, that means we must have an isosceles triangle. Next, a triangle with side lengths of 6 centimeters, 15 centimeters, and 18 centimeters. No side lengths are equal, which makes that triangle scalene. And we have a triangle here with all three sides measuring 19 inches. Therefore, it is an equilateral triangle. Now, we're going to find the unknown measures in the following triangles. Believe that you all know that the total degrees in a triangle is 180 degrees. So let's see. Let's write that up here to remind you. So all we're going to do here is set up equations given angle measures. So we've got a 42 and 42. And some unknown measure, add them all up, we should get 180. So we combine our like terms. 42 plus 42 makes 84. And then we're going to subtract 84 from both sides. Which gives us a value of 96 degrees for x. Bonus question, we've got two angles in here with the same measure. And that does not matter. But we have one angle measure that is obtuse. This is an obtuse triangle. Next, and again, you guys can do this on your own if you want. Pause the video. I'm going to keep going. We have three angles. One of them is 88 degrees. One of them is 40 degrees. One of them is unknown. We add them up. We have a total of 180 degrees because, again, all triangles equal 180. Combine our like terms. 128 plus x equals 180. One step, subtract 128 from both sides. Leaves us with x equal to 52 degrees. So finding unknown measures. Not too difficult as long as you remember that all triangles add up to 180. So since that one seemed kind of easy, or those two did, let's step it up a little bit. We have a challenge problem. Get those fun variables involved here. So again, it's a triangle. Total measures are 180. So we'll just add them up. We have x for the one angle. We have 70 for another angle. And then the third one is 3x plus 10. So, of course, it equals 180. Just do that for the degree symbol. The parentheses mean nothing except just keep that as one measure. So now all we're going to do is combine like terms on the left side. I see an x. I see a 3x. Put it together for 4x. I see a 70 and a 10. Add them up to get 80. Now it's a two-step equation. Subtract 80 from both sides. That goes away. Left with 100 degrees. One step left, divide both sides by 4. X equals 25 degrees. Now, let's check our work by plugging 25 in for x. So, right here, x, as we said, is 25 degrees. If we plug x in here, 3 times 25 is 75. 75 plus 10 is 85 degrees for this angle. And now we just add them all together. 85 plus 25 is 110. 110 plus 70 is 180. It checks out. The final thing we're going to look at in this presentation, we have what is called the triangle inequality theorem. This is not on your notes page. Please add this in. The theorem says any side of a triangle is always, always, always shorter than the sum of the other two sides. For example, we have a triangle here with side lengths of 3 inches, 5 inches, and 7 inches. The sum of any two sides must be greater than the other one. So, we look at 3 inches here. Okay? 3 inches is less than 5 plus 7. 3 is less than 12. It checks out. We look at this one on its own. 5 inches is less than 3 plus 7, which equals 10. 5 is less than 10. It checks out. And finally, we check out, oops, I'm in the wrong spot there. We check out our third side, 7. 7 is hopefully less than 3 plus 5. 7 is less than 8. They all three check out. So again, any side must be shorter than the sum of the other two. Now look at this one. We have a 3, 5, 9. Going through our checks, our side of 3 is less than 5 plus 9. 3 is less than 14, so that works. How about 5? Is 5 less than 3 plus 9? Sure is. 5 is less than 12. That one checks out. But now for our problem. We've got 9 over here. 9 is not less than 3 plus 5. 9 is not less than 8. 9 is greater than 8. Therefore, we cannot have a triangle with these dimensions. That is the theorem. So, test out and see if these are the possible side lengths of triangles. I'm going to go ahead and do them. If you want to pause the video, pause it, or just follow along. 4 is less than 8 plus 2. Checks out. Is 8 less than 4 plus 2? No, it's not. Therefore, this one can't be a triangle. Moving on. Is 5 less than 6 plus 7? Sure is. Checks out. Is 6 less than 5 plus 7? Absolutely. Is 7 less than 5 plus 6? Yes, it is. This one is a triangle. And finally, let's check out the last triangle. Is 6 less than 8 plus 15? Yes, it is. Is 8 less than 6 plus 15? Yes. Is 15 less than 8 plus 6? Uh-oh. It is not. Therefore, this is not a triangle. This concludes your lesson. Please review any slides that you need to. Bring questions to class. If you have any, make sure that note sheet is filled out. Have a good night.